Greetings. This recording covers the lesson on tabular and graphical presentations as ways in describing a set of data. At the end of this lesson, you must have prepared the tabular and graphical presentations of data. Let us start with a tabular presentation. Frequency distribution. Frequency distribution is defined as a grouping of data into mutually exclusive classes, showing the number of observations in each class. These are the steps in constructing a frequency distribution. First, decide the number of classes. Class refers to one of the categories into which data can be classified. Second, determine the class interval or width. Third, set the individual class limits. Fourth, tally the data into the classes. And fifth, count the number of tallies or observations into the classes, called the class frequency. Class or category frequency is the number of observations that fall in a certain category. You may extend the frequency distribution to relative frequency distribution by adding a class relative frequency. Class or category relative frequency is the proportion of the total number of observations that fall in a certain category. Going back to the first step, that is to decide the number of classes, we could apply the 2 to the k rule. In this 2 to the k rule, you select the smallest number k for the number of classes such that 2 raised to k is greater than the number of observations. In relation to the second step, that is to determine the class interval, we could apply this formula. So we determine the highest value, h, and the lowest value, l, in the data set. So from this, we could determine I, the class interval, by taking the difference of the highest and the lowest value, and then divide the result by the number of classes. For better understanding, let us have this example. Given the following grades in mathematics, we are going to construct a distribution of mathematics grades. Step 1. Decide the number of classes. To determine the number of classes, we are going to apply the 2 to the k rule. Hence, we need to determine the number of observations, which we refer as n. In this set of data, there are 21 values. Hence, n is 21. Determine the smallest number, which we refer to as k, such that 2 raised to k is greater than n. If k is equal to 1, then 2 raised to 1 is 2. 2 is less than 21. If k is equal to 2, then 2 raised to 2 is 4. 4 is less than 21. If k is equal to 3, then 2 raised to 3 is 8. 8 is less than 21. If k is 4, then 2 raised to 4 is 16. 16 is less than 21. If k is equal to 5, then 2 raised to 5 is 32. 32 is greater than 21. 2 raised to 5 results to the smallest value greater than 21, hence our k is 5. We will have 5 classes for this distribution. Step 2. Determine the class interval. To determine the class interval, we need to first determine the highest value, which we refer to as h. The highest value in this data set is 95. Hence, our h is 95. Second, determine the lowest value, which we refer as L. The lowest value in this data set is 75. Hence, our L is 75. Third, we compute for the difference between the H and L. The difference between 95 and 75 is 20. Fourth, we divide the result with the number of classes. 20 divided by 5 is 4. I is 4. But we could round it off to a convenient number. Let us say we could use 5 as the class interval. Step 3. Set the individual class limits. Since our lowest value is 75 and seems to be a convenient number, then we will start with it. If the lowest value seems inconvenient, we could start with a lower value which is more convenient. For this step, we could have 75 to 79, 80 to 84, 85 to 89, 90 to 94, and 95 to 99. To determine the boundaries, the common practice is to use the decimal values such as 74.5 to 79.5, 79.5 to 84.5, 84.5 to 89.5, 89.5 to 94.5, and 94.5 to 99.5. However, please be reminded that we prefer using certain values for convenience. Hence, we could simply use convenient numbers for class limits, which serve as our class boundaries as well. In this case, we could just use the following: 75 to 80, 80 to 85, 85 to 90, 90 to 95, and 95 to 100. Again, in this example, our limits and boundaries are the same. It should be noted that the upper limit does not include the value found in the lower limit of the higher class. In other words, the values in a certain class start from the lower limit and does not include the higher limit. For example, 80 is part of the 80 to 85 class and not of the 75 to 80 class. Also, 85 is part of the 85 to 90 class and not of the 80 to 85 class. Step 4. We are to tally the data into the classes. Step 5. We count the number of tallies in each class. For class 75 to 80, we have 3 observations. For 80 to 85, 8. For 85 to 90, 7. For 90 to 95, 2. And for 95 to 100, 1. We can extend the distribution containing the relative frequency denoted by %. It represents the proportion of the total number of observations in each category. Hence, it is computed as a number of observations in a category divided by the total number of observations times 100. Varying practices are employed as to the number of decimal places. If possible, round it off to the nearest ones or hundredth. Conventionally, we use capital N to denote population, while small n for sample. In research, distribution of respondents as found in methodology chapter uses N. But for the distribution found in the results chapter, we use F to denote the number of observation. This is another example, but this involves continuous data. The presentation of using overlapping values in which the upper class limit of the lower class and the lower limit of the preceding upper class are the same, in which again the class limits serve as the class boundaries, is especially preferred for a set of continuous data. For those from qualitative data set, this is an example of the distribution. Now, let's proceed to graphical presentations. There are several graphical options to portray a frequency distribution, but we are going to cover only a few. Please take note that certain computer applications may provide a slight difference in the look of these graphs. First is histogram. Histogram portrays the number of frequencies in each class in the form of rectangles. The classes are marked on the horizontal axis and the class frequencies on the vertical axis. The class frequencies are represented by heights of the bars. The bars are drawn adjacent to each other. On the one side is the tabular presentation of the distribution of income in 1,000 pesos. On the other side is the corresponding distribution in histogram. Histogram is the best option to portray a distribution involving continuous measurements since the bars are adjacent to each other. It depicts continuous values. Both the table and the histogram show that there is one person with an income between 5 to 15,000 pesos, 5 persons with an income between 15 to 25,000 pesos, 11 with an income between 25 to 35,000 pesos, 3 with an income between 35 to 45,000 pesos, and 1 with an income between 45 to 55,000 pesos. Most of them earn between 25 to 35,000 pesos. Had we used inconvenient numbers in our class limits, then phrasing our observations and interpretations would not be easy. This is another way of depicting a histogram. This one is using the midpoints in the horizontal axis instead of the class boundaries. The midpoint is determined by adding the upper and lower boundaries, then divide the result by 2. Please take note that the midpoint is at the center of the bar and neither in the beginning nor the end of it. Another graphical presentation is with frequency polygon. It consists of line segments connecting the points formed by the intersections of the class midpoints and the class frequencies. Both the table and the frequency polygon shows the distribution of sales in 1,000 pesos. In frequency distribution, the horizontal axis marks the midpoint while the vertical marks the frequency. Another graphical presentation is cumulative polygon. This one is similar to frequency polygon, only that we use the cumulative frequency instead of the frequencies only. Cumulative frequency polygon shows the number of observations below a certain value. With the same values in the previous example, both the table and the cumulative frequency polygon depict the distribution of sales in 1,000 pesos. Cumulative frequency is the sum of the frequency from the previous class and the current class. That is, there is one observation in 0 to 10,000 pesos class. The cumulative frequency is 1 because this is the initial class. There are 5 observations in 10 to 20,000 pesos class. The cumulative frequency is 1 based on the previous class, plus 5 in the current class, which is equal to 6. There are 11 observations in 20 to 30,000 pesos class. The cumulative frequency is 6 based on the previous class, plus 11 in the current class, which is equal to 17. There are 3 observations in 30 to 40,000 pesos class. The cumulative frequency is 17 plus 3, which is equal to 20. There is 1 observation in 40 to 50,000 pesos class. The cumulative frequency is 20 plus 1, which is equal to 21. This graphical presentation uses the class boundaries instead of the midpoints. Specifically, we use the upper boundary of each class in plotting against the corresponding cumulative frequency. Next graphical presentation is the line chart. Line chart looks like a frequency polygon. It is ideal for showing the trend of certain variable over time. This is an example of the use of line chart. The table shows the corresponding sales for each year. Opposite to it is the line chart. Another one is the bar chart. Bar chart looks like a histogram, but with gaps between bars. Moreover, it is similar to line chart that shows trends, but usually depicting nominal scale data. This shows the variations of a bar chart, the vertical and the horizontal. Both charts depict the average salary depending on the educational level. Either of the graphs shows that the salary increases as the educational level gets higher. The last one in this lesson is the pie chart. It is useful for showing the percent that various components are of the total. Usually, it is used for presenting nominal scale data. On the one hand, it shows the breakdown between female and male. On the other hand, it depicts the breakdown in terms of civil status. This marks the end of our lesson on tabular and graphical presentations.